All right, guys, take a seat. Take a seat. Before we get started, are there questions over the homework? Question over homework assignments.
Did we submit our turnout sheet yesterday?
We did not.
Huh?
4, 2, 4, 5, 6. Who are we missing? 5, 6, 7.
4.4.
I'll address that here in a second.
No.
Who are we missing? Cassidy. Okay. Yes. I'll address that here in a second. No. So everybody has a graphing calculator, yes? All right. So before we get started with 4.5, I do know that we started 4.4 yesterday. Guys, let's focus up here. So I know we started 4.4 yesterday. The original plan was to do 4.4.1 yesterday, 4.2 today, 4.4.2, and then 4.5, 4.6. But because yesterday's notes took more than a day than I was expecting, we're not going to quite have enough time to finish all of 4.4 and do everything else and have enough time to test and everything else. So instead of trying to continue with that and go through that, I've just made all of 4.4, part 1s and 2, a bonus assignment. Now in Google Classroom, so in Google Classroom, we're in second hour, I did go on and add it. So this here. So the assignments that we were originally going to have are up there. The videos for the full thing are up there. It's all up there. Now, for the most part, what that adds is factoring. The only other part that we didn't go over with 4.4.1 is factoring by grouping. And in 4.4.2, we got something called the factor theorem. And the factor theorem stated that x minus a is a factor of the polynomial if and only if, when we did the division of our original polynomial divided by our x minus a, the remainder was 0. If the remainder of what we're dividing by our value of a in synthetic division gives us a remainder of 0, it means that value is a factor. Or more specifically, we end up getting the fact that it's also a solution. That value of a is a solution for the polynomial function. So there's not a whole lot that it does add. So removing it doesn't hurt. But I did put it back in there, so if y'all want to finish up the last bit, it's only a few things with factoring by grouping. And then the assignment is a bonus assignment, so if you do the assignment, turn it in, I will give you bonus points for doing that, okay? But what I want to get to is solving. What we need to get to is solving. And at the rate that I'm planning on us going, we should finish, well, we'll definitely finish 4.5 this week. We'll probably finish 4.6 Monday, review, and then get ready for the test. Now, solving. Solving is what 4.5 and 4.6 is all about. That's all that we have left. Now, even with 4.4 missing, it doesn't give us any real solid methods for solving these cubics, quartics, quintics, these higher degree polynomial functions. All the methods that we know so far really revolve around quadratics. And there's essentially 4 main ways, 5 if we include the square root method, that we know how to solve. The first one is to factor. We factored into our multiple sets of parentheses, set equal to 0. Whenever we have more than one thing multiplied together to equal 0, one of them must be 0. and we can set them equal to 0 and solve. Our second one is graphing. And luckily, we're not going to have to graph these by hand because the graphing calculator will help us with these. But whenever we graph, especially our quadratics, we were looking for what value of x made the y value be 0. When x is 0, that y value is the y-intercept. Because we're not too focused on the y-intercept, we're mainly focused on the x-intercepts with graphing. Our values of x that make the y be 0. Then we also have the quadratic formula and completing the square. And while the quadratic formula and completing the square mainly work with quadratics, our degree 2 polynomial functions. And so the main goal with most of these here is either using factoring or graphing to get it down to a quadratic. Because if I can get it down to a degree 2, we can use the quadratic formula. We can use completing the square. Or we can also use the square root method. Because our square root method is if we don't have a middle term, we just have x squared and a constant number. Get the x squared term by itself, square root both sides, and we're done. But that's the main goal. And most of the time, graphing will give us some of the solutions, some of our zeros. And then we can use long division or synthetic division to find the rest. Because it worked out every time we used, you don't have to write this part down, synthetic division, and we had a number in here. Numbers across the top, and did our synthetic division steps. The degree of what we got, the solution from doing each synthetic division or long division, was always less than what we started with. So here, the degree is 1, 2, 3, 4, degree 5, and our solution will be a degree 4. So with every solution we have, and according to the factor theorem, if it's a factor, the remainder is 0, which means it divides evenly, which means it is a solution. For each solution we have, we can decrease the degree by 1. Well, if I start out with a degree 5 and where we need to get to is a degree 2, I only need 3 solutions, because if I have at least 3, we can find the rest. And we will get a theorem. I don't want to start a survey. That actually tells us, and we will know for certain how many solutions we should have. Now the first two we're going to look at with factoring. So some of the factoring we did yesterday. We're not so much going to be completing our sum or difference of perfect cubes. But when we do look at this here, 2x cubed minus 12x squared plus 18x equals 0. Is there a greatest common factor between these three terms? 2x. Which we can factor out. Because if we take a 2x out of 2x cubed, we're left with x squared. Minus, if we factor a 2x out of 12x squared, so 6x plus 9. And I will say, especially when we start solving any of these here, if there's a greatest common factor, be it a number or variable, factor it out because it makes these easier or simpler to solve. Because just by factoring out the 2x, we took it from a cubic, a degree 3, down to a degree 2. X squared minus 6x plus 9. We have been factoring those in chapter 3. This is something we've done already. So just by pulling that 2x out, we have something that we can factor. Now the first thing we need to do after our two sets of parentheses with 3 spaces is to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Well, here the third term is positive. So the signs are the same and match the sign of the middle term. So we have negative and negative. Factors of the first and third term, factors of x squared and 9. Factors of x squared are x and x. Well, our factors of 9 are 1 and 9 or 3 and 3. Which one do we want to try first? 3 and 3. And off to the side, we can check this. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3x minus 3x is negative 6x, which is the middle term we wanted. Yes? Questions on how we factored this? Now at this point here, we do have two or more things multiplied together to equal 0. So one of them must be 0. So we're saying either 2x is 0, x minus 3 is 0, or x minus 3 is 0. Now we can look at 2x equals 0 first, and there's two ways we can do this. Because one way is what? We divide both sides by 2, yes? Divide both sides by 2. 2x divided by 2 is x. 0 divided by 2 is 0, so x is 0, yes? But in that statement also, we have 2 times x is what? 0, yes? Whenever we have two or more things multiplied together to equal 0, one of them must be 0, yes? I can't plug a value in for 2, it's 2, yes? So the only place we can plug a value in is x, so x has to be 0. Now the next one, x minus 3, first thing we can do is add 3 to both sides, telling us x is 3. And lastly, we can add 3 to both sides, telling us x is. So the solutions for this one here is x is equal to 0, x is equal to 3, and x is equal to 3. Now the solution x equals 3, we consider it to have an even multiplicity. Even because it appears twice. Multiplicity means just multiple times, so it has an even number of zeros at 3. But we have 3 and 0. That's it. Questions on this here? Now, if you're not sure about one of the zeros, if it's the correct one, all we have to do is check it. We can plug it back into the original equation. 2 times 3 to the third minus 16 times 3, I don't think it's, is it 6? 12. Maybe that didn't seem right. 12 times 3 squared plus 18 times 3. And we get 0. So it confirms that that is the solution because this equation was supposed to equal 0. Now we could do the same thing, except instead of having 3, we can type it in as 0, and that would also give us 0. So it does tell us those two, 0, 3, and 3, are the solutions. Questions on this here? Let's look at another one. 5x cubed minus 40x squared plus 80x. Is there a greatest common factor? Yes, 5, 40, and 80 all do have a common factor of 5. And we also have x. And if we take 5x out of 5x cubed, 5 factors out completely, and our x cubed goes to x squared. Minus 40 divided by 5 is 8, if we take an x away from x squared, the left of the single x, plus 80 divided by 5 is 16. So we have 5x times x squared minus 8x plus 16. Questions on this so far? Now at this point here, we know, or at least when we talked about cubics, sum and difference of perfect cubes yesterday, we did say this quadratic part of the sum or difference of perfect cubes never factors. It will have complex solutions. So I will give you something here. If you're not sure if something's going to factor, square root of b squared minus 4ac. This should look somewhat familiar. This is part of the quadratic formula. And it works out that if the square root of b squared minus 4ac is a whole number, 0, 1, 2, 3, a non-decimal positive number, then our quadratic is factorable. It will factor. But if it gives us a decimal or gives us complex imaginary terms, then it's not. So it's an easy way to be able to check to see if something is factorable. And here, we can pull up the 30xs, second square root. I think it's negative 8. Squared minus 4 times 1 times 16. And that gives us 0. So what that's telling us is that it is factorable. If we get a decimal number, or for the 30xs, it gives us a radical back, it's not factorable. If it gives us a domain error, or it throws up an error, because that just means what's inside the radical is a negative, it means we have complex solutions, and it doesn't work. Now, the reason I put the square root with this, even with the risk of it coming out as a negative number inside, is I'm not solving. I'm just seeing, is this factorable? So if I get something other than a nice whole number, then I know it doesn't factor. So it's just a way to check. Now, knowing that, we know that we can factor this x squared minus 8x plus 16. If the third term is positive, the signs are the same and match the sign of the middle term, which is negative, negative, and negative. Factors of x squared are x and x. Our factors of 16 are 1 and 16, 2 and 8, 4 and 4. Which one do we want to try first? 4 and 4. Now at this point here, we can check x times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4x minus 4x is negative 8x, which is the middle term we wanted. Questions on this so far? Questions on anything we've done so far? Now that we have three things multiplied together equals 0, one of them must be 0. 5 times x equals 0. Divide by 5, it's just going to tell us x is 0. X minus 4 is equal to 0, we would. Add 4, telling us x is 4. And lastly, we would add 4, telling us x is 4. X is equal to 0, x is equal to 4, and x is equal to 4. That's it. Questions on these here? We ready for the next one? Finding the zeros of a polynomial function f of x equals negative 2x to the fourth plus 16x squared minus 32. And then graph it. Why don't we just go on and graph it? So let's use the graphing calculator. So the first thing we need to do after turning it on is to hit y equals. Y equals. And then we're going to type the function in. Negative 2x to the fourth plus 16x squared. Well, might help if I get out of the exponent. Plus 16x squared minus 32. Questions on typing this in? Good. So y equals? Y equals first, and then negative 2. The number above the caret key, or number above division, gives us our exponent. The other way to do it is our x squared button will give us that. We just have to cursor over and fix it. Yep. One more. One more. There you go. Once you get it all typed in, hit graph. So, x to the fourth plus next to alpha x to the fourth plus 16x squared minus 32 x. Zoom 6. Zoom up at the top. 6. Make it look a little better. Did most of y'all get something that looks like this here? Yes. Oh.
Not me. I know what's going on. Mode. Wait. Almost like function. Just like me.
There we go. Something got turned on. I just had to reset it. So, are we all able to get this graph here? Now, whenever we graph a function and we're trying to find its solutions, we're trying to find out what values of x make the y value be 0. So what's one of our solutions? second graph. Second graph. So we see that two of the solutions are -2 and 2. And with graphing, what we're really doing and using is we're finding zeros to decrease the degree down to at least a quadratic, and we can solve from there. If we can decrease it further, that makes it even easier to solve. So we know for certain that x is indeed 2, and x is -2. Now we're going to do synthetic division. Now we only need 2 lines if what we're dividing by has more than one term. Here, since we're only doing a single number, a single 0, we're only going to need 1 line. And the first thing we'll do is bring down the -2. Our 2 times -2 is -4. 0 plus -4 is -4. 2 times our -4 is -8. 16 plus -8 is 8. 2 times 8 is 16. 0 plus 16 is 16, and 2 times 16 is 32. And lastly, -32 plus 32 is 0. And we knew the remainder was going to be 0, because if the remainder is 0, it's a factor, which also means it's a solution. Well, that decreased the degree, because our starting degree was a degree 4. Now it's a degree 3. Because I'm going to put the variables back in, I wouldn't write them in, because I'm going to immediately erase them. Because we had remainder, constant, term with x squared, and term with x cubed. So the biggest term is x cubed, so the degree is now 3. It was 4. So it's always going to decrease by the degree of what we're dividing by. And with all these here, all we're dividing by is a degree 1. Well, it's going to be a lot nicer if it is a quadratic. But we did have a second solution that was given to us by the graph, which was -2. And if we divide this by -2, -2 times -2 is +4. -4 plus 4 is -2 times 0 is 8 plus 0 is. Lastly, -2 times 8 is -16. And 16 plus -16 is. And again, that's what we expected to happen because -2 was a solution. It gave us a y value of 0, so the remainder should be 0. Now it is a quadratic. The degree went from 4 to 3, from 3 to 2. Now if I put the variables back in, I would, yes. Constant is our 8. 0 is our x. -2 is our x squared. So what we have left is -2x squared plus 8 equals 0. And as a side note, we took this from -2x to the 4th plus 16x squared minus 32. Graphed it, found 2 solutions, and brought it down to -2x squared plus 8. Technically, it is possible to factor our original equation. We graphed it. We found 2 solutions, and we took it from something that we didn't quite know how to solve to something we do. Because we've covered these here. as our negative 2x squared plus 8, we can use our square root method. Since there's no middle term, get x squared by itself. So the first thing we can do is subtract 8, telling us negative 2x squared is equal to negative 8. Then we would almost divide by negative 2, telling us x squared is equal to 4. And last but not least, we would x is equal to plus or minus 2. Because whenever we square root both sides, we need the positive and negative. Because 2 squared is 4, and negative 2 squared is also 4. So what that told us is that x is equal to plus or minus 2. And we also found that x is 2 and x is negative 2. So it works out, actually, 2 and negative 2 have an even multiplicity. They show up twice. And that's the answer. Now the question also is, could we have graphed negative 2x squared plus 8? Let's see. Negative 2x squared plus 8. Graph. Yes. And negative 2x squared plus 8 says that the solutions are negative 2 and positive 2. So it would also given us those. Question? Huh? Yes. Now, will all the answers always show up on the graph? Not always, because if they're imaginary solutions, then they don't show up in the table. Irrational solutions are square root of 3. If it came up as a solution, it would show up on the graph. We'd have to do some manipulations of the table to get us to show the square root of 3. So it'd take a little more work there. But we're not going to have one, at least in this class, where we have multiple imaginary or multiple radical solutions in the same one. Because at most we'll have either one set of imaginary or one set of irrational square root answers. If there's more than one, it will be told to you that there's going to be what one of the imaginary or one of the rational or one of the irrationals is. Questions on this here? Let's look at this one here. X to the fourth minus 18x squared plus 81. Let's graph it first. Y equals x to the fourth minus 18x squared plus 81. And we already went and hit graph. Is everybody able to get this one graphed? Yes? So we see this here. We do see that it intersects the x-axis and goes back up. It does look very similar to the one we had previously. Yes? Now, if we look at the table, second table, the solutions that we see are negative 3 and 3. So for us here, for this equation, we know that x is equal to 3 and x is equal to negative 3. And as we saw in the last one, our degree 4 had 4 solutions, and the two prior were degree 3s, and they had 3 solutions. So based off that, there's a good chance this one also has 4, even though they might be repeated. Now the numbers going across the top are going to be 1, 0, negative 18, 0, and 81. Which number do we want to try first? 3 or negative 3? 3. So we do our synthetic division of 3, and we know that the number at the end here should be 0. Now let's see and make sure. 3 times 1 is 3. We put it under our 0. We add straight down. 0 plus 3 is 3. Then we do our multiplication again. 3 times 3 is 9. Negative 18 plus 9 is negative 9. 3 times negative 9 is negative 27. 0 plus negative 27 is, and 3 times negative 27. 3 times negative 27 is negative 81, which does indeed give us 0. I will also say, if you need to use a calculator for this, go on and use a calculator. 3 times the number, add it, multiply, add it, and work it out, because it will help you get the correct answer. Now, the graph of this one looked very similar to the one we did prior, yes? And on the last one, the zeros were repeated, yes? Well, there's nothing that says I couldn't try 3 a second time. Now, each time we do the division of a solution, it removes it from the remaining solutions. So if 3 only appears once, we did it once, it won't work again. But if it works a second time, it means that solution was there twice. If it works a third time, it means it's there 3 times. Because each time we divide by a solution, we remove it from the solution set. So if we do this again, and we get a remainder of 0, it means 3 was a solution twice. Now our 3 times 1 is 3. 3 plus 3 is 6. 3 times 6 is 18. Negative 9 plus 18 is 9. 3 times 9 is, and negative 27 plus 27 is 0. Well, okay. That means 3 worked twice, yes? There's a good chance, yes. There's a good chance negative 3 is also going to work twice. Now at this point we have it as a quadratic, yes? And on the last one we put the variables back in and solved by factoring or solved by the square root method, yes? Do I have another possible 0? Negative 3. Well, getting it from a degree 4 down to a degree 3, down to a degree 2, we can solve degree 2's, yes? But what's nicer than a degree 2 is a degree 1. Because a 1 degree is just a linear equation. And if we do this one more time, negative 1, or negative 3 times 1 is 6 plus negative 3 is 3. Negative 3 times 3 is 0. Now, we could plug negative 3 in again, or I'm going to put the variables back in, because 0 is our remainder. 3 is our term without x. 1 is our term with x, leaving us with and lo and behold, the last solution is x is. Now, the reason this works this way, and we can kind of tell that these solutions are repeated, is because when we looked at the graph touched the x-axis but didn't cross it. Anytime the graph intersects the x-axis for these higher degree polynomial functions, it means that 0 is repeated an even number of times. So that means it's either going to appear twice, 4 times, 6, 8, 10, 12. So anytime it touches it and doesn't cross, we have an even number of zeros. Now it could be with odd degree polynomial functions, because a cubic could have one that repeats twice. Questions on this here? Now, I know we're running short on time, but let's look at this one here. 4x to the fourth minus 40x squared plus 36. So I typed it in and got this graph. How many times does it cross the x-axis?
4.
So our solutions are -3, -1, 1, and 3. Now, unfortunately, we don't have quite the time to go through the synthetic division of these here. I did that in the other hours, but I could divide it, the original problem, by -3, and then divide the result by -1, divide that result by 1, and then we would get x minus 3 equals 0, which tells us x is 3. So here it gave us all 4. Now, as I said earlier, I did make the comment that if there is a greatest common factor, makes it easier to solve these, makes them easier to reduce. Here, there's a greatest common factor of 4. And if I divide it out, what we're left with is x to the fourth minus 10x squared plus 9. Graph. Now, if you notice, some of the graph is different because the one in blue does go higher in the middle, but the zeros, where it crosses the x-axis, are still the same. Everything else, the numbers are obviously different. But we're not worried about everything else. We're just worried about the solutions. One thing I will highly advise against is you can divide out numbers. If there's a constant number across all of them, we can divide it out, we can multiply it through. Do not divide by a variable. Because as we saw with solving, anytime we divide the number out, a solution out, it removes it. Same thing's true with variables. We will continue this tomorrow. If I gave you or let you borrow one of the fancy calculators, do turn them back in.